Hello friends, this video on Neet Semiconductor Electronics is brought to you by examfear.com. No more fear from exam. Question number 29. For a transistor IC by IE is equal to 0.96. The current gain in common emitter configuration is. Now, what would be the current gain? If we are talking about current gain in common emitter configuration, then current gain would be equal to the output current, which is collector current, by input current, which is base current, because we are talking about common emitter configuration, right? And what is IC by IE? This is current gain for common base configuration, because in common base configuration the input current would be IE, that is emitter current. So how do we represent these two? So we know that IC by IE, which is current gain in common emitter configuration, is represented by beta, and the current gain in common base configuration is represented by alpha. Now, if at all you remember the relationship between alpha and beta, it is beta is equal to alpha divided by 1 minus alpha. So it's pretty simple. If you put the value, it is 0.96 divided by 1 minus 0.96. This comes out to be 0.96 divided by 0.04, which is equal to 24. So the correct option is C. Now, a lot of you might wonder that how did I directly write this expression? Well, this is an expression which you are supposed to remember, because in your competitive exams, if you remember the expressions, it becomes easy. You do not need to derive it completely. But for all of those who do not remember how do we get this, I'll just quickly give you some idea. So we know that the emitter current is equal to the base current plus the collector current, and we also know that beta is equal to collector current by base current. So this can be written as IC by IE multiplied by IE by IB. So we basically multiply and divide by IE, right? So IC by IE, what is this? This can be written as alpha. So alpha into IE by IB. So how can we write this IE by IB? So IE can be written as IB plus IC. So this can be written as IB plus IC divided by IB. So this further can be written as 1 plus IC by IB. And what is IC by IB? IC by IB is equal to beta. So this is alpha into 1 plus beta. So now if we have to write this expression further, it would be beta is equal to alpha plus alpha beta. Now if we have to write it in terms of beta, we will pull all the beta in one side. So this is how it would be: beta 1 minus alpha is equal to alpha. Therefore, beta is equal to alpha divided by 1 minus alpha. So this is just simple mathematics. Now, in your NEET exam, if you spend so much time deriving the expression, it will be a waste of time. So it is better to remember these important expressions. Question number 30. Which one of the following gates will have an output 1? So let us analyze each of these. So this is a NAND gate. Now in AND gate, so therefore the output will be A, B bar. So A is 1, B is 1. So A 1 into 1 is 1, bar, that is 0. So the output will be 0. This is a NOR gate. That is A plus B bar. So 1 plus 1 is 1, but bar, so it is 0. What about this? This is again a NAND gate. So in this case also it will be A, B bar. So 1 into 0 is 0, 0 bar is 1. So here the output is 1. So correct option is C. Let's also analyze the third one, which is a XNOR gate or a XOR gate. So this one, so this one is XNOR gate. So in XNOR gate the output is AB bar plus AB. So AB bar, it is 0 into 0. So 0 bar is 1 plus AB. So 0 into 0 is 0. So here also the output will be 1. So this should also be a correct option. So that means here we have both the options correct, C as well as D. Now the question says which one of the following gates will have an output 1. So that means there is some discrepancy. So that means either the last gate should have been a XOR gate. In that case, the output would have been 0. But the correct option here would be both C and D. Question number 31. A semiconducting device is connected in a series in circuit with a battery and a resistance. A current is allowed to pass through the circuit. If the polarity of the battery is reversed, the current drops almost to zero. The device may be okay. So, what do we see? The moment polarity is reversed, then the current that flows is almost negligible. Now that generally happens in a PN junction because a PN junction conducts current when it is forward biased and it doesn't conduct current, or it conducts very negligible amount of current when it is reverse biased. So it is a PN junction. Question number 32. The diode used in the circuit shown in the figure has a constant voltage drop of 0.5 volts at all currents and a maximum power rating of 100 milliwatt. What should be the value of the resistor R connected in series with the diode for obtaining maximum current I? Now in this case, in order to calculate the value of R, what do we need to do? So R will be equal to the value of voltage across R divided by the current that is flowing through R. So this is small I. So the current flowing through R, right? So for that we will first have to find out the value of current. So how do we calculate current? So current will be equal to, here in this question power is given, right? So in terms of power, current will be equal to power divided by voltage of the diode, or voltage drop across the diode. So this is the diode, right? So this will be equal to, power is 100 milliwatt, that is 100 into 10 to the power minus 3 watts, divided by voltage drop across the diode is 0.5 volts. So therefore current will be equal to 0.2 ampere. Right? Now what will be the voltage across the resistance R? So the voltage across the resistance R would be equal to the total voltage minus the voltage across the diode. So total voltage is 1.5 volt minus the voltage drop across diode, which is 0.5, that is equal to 1 volt. So now we have the value of voltage across the resistance R, and we also have the value of I. So therefore R will be equal to 1 volt divided by 0.2 ampere, which is equal to 10 by 2, that is 5 ohms. So correct option is C. Question number 33. When a NPN transistor is used as an amplifier, then the electrons flow from emitter to collector, holes flow from emitter to collector, electrons flow from collector to emitter, electrons flow from battery to emitter. Now, what happens in NPN? Let us say this is NPN. So, NPN. So in NPN, electrons are the majority carriers, and we know that base is very thin and it is lightly doped. Therefore, it has less number of holes. Now, as electrons enter the base, only few get neutralized. Rest of the electrons, they move to the collector. So as a result, the base current is very small. So base current is just 5% of the emitter current. Emitter current is the input current, right? But the collector current is very high because most of the electrons, they move towards the collector. So collector current is the remaining 95% of the emitter current, right? So with this, keeping this in mind, what do we understand? That the electrons flow from emitter to collector. Yes, of course, because as you will see, very few electrons will get neutralized at the base, rest will all move to the collector. Question number 34. In the figure, the input is across the terminals A and C. That means the input is across these two terminals, and the output is across B and D, these two. Then the output is, so what would be the output? So let us say if the input is across A and C, what happens? When the input comes at A, it has to pass through these diodes. Let us call this D1, this is D2, this is D3, and this is D4, right? So now whenever there is an input which has to pass through D1, now let us say, now how does your input look like? So let's say the input is somewhat like this. Now, when the input passes through D1 during the positive, now first we are talking about the positive cycle of the input. So, when the positive cycle passes, in that case, D1 is forward biased, but D2 will be in reverse biased, right? So, as a result, if you actually look at the output, so the output would be somewhat like this, which is due to D1, right? Now again, as the input passes through D3 and D4, we actually see that D3 again is reverse biased and D4 is forward biased. So this is during the positive cycle. So during the positive cycle, the output will be because of D1 and D4. So that means this output is because of D1 and D4. Now, when we talk about the negative cycle, then what happens? In case of the negative cycle, the D1 diode becomes reverse biased, but D2 becomes forward biased. D3 is also forward biased, and D4 becomes reverse biased. So now this time also the output will be positive, but this time it is because of D2 and D3. So basically we see that the output would be like this, like the output is similar to that of a full wave rectifier. Why? Because in half wave rectifier you actually get a high output in the first cycle, and in the negative cycle you do not get high output, and again in the third cycle you get high output. But in this case the output is like the full wave rectifier, because you have diodes alternately placed. So in one cycle, one diode is forward biased, in the other cycle, the other diode is forward biased. So therefore, the output that we get is full wave rectified. Question number 35. A piece of copper and other of germanium are cooled from the room temperature to 80 kelvins. Then the resistance will increase, resistance will decrease, resistance for copper will increase, for germanium will decrease, resistance of copper will decrease, that of germanium will increase. Now first we have to understand that here we have copper, which is a conductor or a metal, and we have germanium, which is a semiconductor. Now in case of semiconductors, if we talk about semiconductors, we know that they have a negative temperature coefficient of resistance. That means their resistance decreases with increase in temperature. Whereas if we talk about conductors, they have a positive temperature coefficient of resistance. Right? That means their resistance increases with increase in temperature. Now in this case, what is happening? Both of these are cooled from room temperature. That means their temperature is decreasing. So temperature decreasing means the resistance for conductor will decrease, resistance for semiconductor will increase. So that means resistance of copper will decrease and resistance for germanium will increase. So the correct option is D. Now why does this happen so? That is because in case of semiconductors, when we increase the temperature, the number of electrons in the conduction band increases. Therefore the conductivity increases and therefore resistance decreases. Whereas in case of conductors, when the temperature is increased, the collision of electrons increases, and therefore the resistance also increases. Question number 36. At absolute zero, silicon acts as non-metal, metal, insulator, none of the above. Now, silicon is a semiconductor with a negative temperature coefficient of resistance. However, at absolute zero, if we are talking about, it behaves like an insulator. But when the temperature is increased, at very high temperature, it behaves like a conductor, because some of the electrons, they jump from, so silicon is a semiconductor, so it doesn't have overlapping valence band and conduction band. So let's say if this is the valence band, this is the conduction band, there is some gap in case of silicon also. So at absolute zero, it behaves like insulator. But when the temperature is increased, so when temperature is 0 Kelvin, then it behaves like insulator. But when temperature is increased, when temperature is greater than 0 Kelvin, in that case what happens? Then the electrons are able to jump from the valence band to the conduction band, and as a result it behaves like a conductor, and that is why it is called a semiconductor. So at absolute zero, it behaves like an insulator, that is option C. So with this, we have reached towards the end of this lesson on semiconductor electronics. So I have tried to solve a lot of questions which have been asked in previous year's NEET exam. So please look at these questions, understand them thoroughly, and then start practicing sample papers, and I'm sure it will help you. So see you all very soon with a new topic, with a new lesson. And if you have liked the video, do not forget to share it with your friends too.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.